Our world and beyond. Space, in partnership with the European Space Agency.
For just a few seconds, it's like being in space. Welcome to the weightless world of the parabolic flight.
This moment when microgravity occurs, it's unbelievable. It's like a cloud picking you up and bringing you softly into the sky.
Passengers on a parabolic flight have 22 seconds to spin free from the ties of gravity.
A parabolic flight means the plane follows a bell-shaped curve. We literally throw the airplane into the air, we send it into orbit, but it's an orbit that's within our atmosphere.
The plane being thrown into orbit is effectively a normal airliner.
It's a standard airplane. The wings haven't been modified, the fuselage hasn't been modified, the engines haven't been modified.
At the top of the parabolic curve, something rather magical happens.
When you're floating around in zero-G during a parabolic flight, you aren't touching either the sides or the floor. The weightlessness is exactly the same as in the Space Shuttle or the International Space Station.
Parabolic flights are one of the best ways to simulate the environment of space, and those preparing to fly are scientists with a special interest in microgravity. To be on board the Novice Pass zero-G plane, the researchers have proven their experiments are scientifically sound and pass rigorous safety checks. One of the teams taking off from Bordeaux Airport today is from the German sport university Cologne. They're curious to find out how our brains work in microgravity.
We're really interested to see what's happening to the brain in weightlessness. There's a redistribution of blood volume. The blood volume is no longer sucked downwards, but it's distributed all in the body. That means an increase in intracranial pressure. And we like to see whether this has a negative impact on brain cortical activity.
Close by is a team from Munich who want to see what position the human body takes when it's not under the influence of gravity.
We're aiming to gather an understanding on the relaxation behavior of humans in microgravity. In ergonomics, there's something called a neutral posture, a zero posture. And to really document this posture, you have to go to microgravity.
It's not all about the science of the human body. This French team wants to understand heat transfer around bubbles in boiling liquids.
When you go into weightlessness, you change the transportation of heat. You can't boil water in the same way, with the same efficiency. At the same temperature, the pressure changes, the temperature changes. The physics change in weightlessness. But in order to study this phenomenon, the boiling point, you have to study at the scale of one single bubble.
Once up to 6,000 meters, the crew is ready for the first parabola.
The two pilots fly the plane at the same time during the parabolic curves. That's to say there's a pilot for pitch who's going to pilot the load factor. He has this add-on joystick. It's not the real joystick, it's something that we've put on there that allows the pitch pilot to raise and lower the nose of the aircraft.
Why don't we wait here? I just wanna stay here. Why don't we wait here now?
The crew will fly 31 parabola, throwing those on board into weightlessness 31 times. But after just 2 parabola, the French team knows something is wrong. The special liquid they want to study has leaked out and evaporated into the air.
We were just hoping to have results, good results, and in the end it transpires that we had a technical problem right from the start. We had a problem with a tube connection, and we lost our fluid that we were going to use in our experiment, so we had to stop the experiment after 15 minutes.
At the other end of the plane, all's going well for the team studying the human neutral body posture.
What's happening in the experiment?
Well, our subject is still strapped in, blindfolded, and we have music running, and he gets all the commands on there. And we see very interesting postures right now, something that we had calculated on the floor.
Across the aisle is the team led by sports scientist Stefan Schneider. It's tough for his volunteers to concentrate as the plane pulls up at over 40 degrees and then plunges back down again.
During the flight, I kept my hands on both of them just to stabilize them a little bit. They were secured by a stripe, but obviously they were able to lift up for 5 or 10 centimeters. And I just wanted to tell them, well, I'm here, I take care for you, and I'll hold you, don't worry. You can relax, I'll still have my hand on you.
Stefan is monitoring how they perform simple calculations while weightless. To get clear data, the pair can't take any travel sickness drugs.
So we are nearly finished our experiment. There's one last measurement. Everyone was really fine. They got a little bit sick, but I really enjoyed it and they really pushed hard, so we got all our data. That's great.
As the aircraft curves through the sky, the volunteers on Tom Derlich's experiment lift freely into the air, attached only at the hip. Everything they do is captured on camera.
The video data we transform into a stream of pictures. Each of the 3 cameras delivers a stream of pictures, and each 3 pictures are synchronized and then put through a special software we're using to create a 3-dimensional model of the human posture at that point in time.
The pilots continue to be utterly focused.
The other pilot is the roll pilot, who with these 2 pieces of string has to make sure that the wings stay horizontal over the course of the maneuver. So these allow him to work on the roll axis without interfering with the pitch pilot.
As the last of the parabola come to an end, the scientists are already learning from what they've seen. So, do our brains work differently without gravity?
Currently, I don't think that there's an impact of gravity itself. I think it's more the stress. So we will probably see a delay in the reaction time, a delay in the brain cortical activity throughout the flight. The more stressed they are, the more the brain has to do, and therefore it can't locate resources to this main task, but it allocates resources also to other tasks. For example, their inner perception of feeling really sick.
The team studying human-neutral body posture have had a superb flight. None of the volunteers were ill, even without travel sickness drugs, and the science was good.
We could see some interesting oscillations over the body when the body tries to react to entering microgravity. The body tries to find a new, let's say, center of gravity for itself, and that's very interesting to see how we had 3 different subjects, how they behaved.
The French trio can't salvage the experiment and will have to start again tomorrow.
It's pretty stressful. It's 6 months of preparation. We're allowed just 3 flights of 30 parabola each, so wasting a flight is wasting a third of our experiment time.
3 hours and over 11 minutes of cumulated weightlessness later, it's back to base for a team photo and debrief session. Novice Pass flies several parabolic flights per year for clients like the European Space Agency, and not all involve zero gravity. Some recreate the gravity of other planets instead.
We've qualified parabolic maneuvers to reproduce reduced gravity environments, so not like zero-G, not weightlessness, but reduced, like the gravity on the Moon or Mars. So you feel exactly what you'd feel if you were standing up on the planet Mars. Once a year we have a flight campaign that's entirely dedicated to research on lunar or Martian gravity in order to test equipment that astronauts or robots may need, instruments to dig or push onto the surface of the Moon or Mars.
I just wanna stay here.
The next step is commercial flights, with paying members of the public now able to feel what it's like being in space.